everyone, today in this video we're going to be learning more about distributive property and how we can use it to expand within fractions as a whole. So sometimes they're going to be you're going to have to expand an expression using that has fractions, and you're going to have to use distributive property to simplify and expand that expression. So sometimes you're going to have fractions either on the outside of the expression, or you're going to have fractions on the inside of the expression. So today we're going to learn more about how to use distributive property. So what we want to know before we even do our distributive property is that the first thing we want to learn is that this x and y is multiplied to the quantity of b divided by y minus c. So if we were to apply distributive property, right, we would multiply our numerators together, as well as we would multiply all of our denominators together. So this xy would actually multiply to this b and y. That would mean just the x would get multiplied to the b, and the y would just get multiplied to the y over here. As well as this x would also get multiplied to this negative c right here. So xy times negative c, and then always remember that this value by itself is divided by 1. So always remember it's divided by 1. It doesn't change the equation or the expression. So always remember it's going to be, if a number is by itself, it's divided by 1. So let's try using distributive property. Well, since we know that this x divided by y is going to be multiplied by the quantity of b divided by y minus c over 1, what we can conclude is we're going to do our numerators first. So x times b, so this is going to equal x times b, and then we have our y's together. So y times y is going to be y squared. Right now I'm going to leave it in this format, and we're going to simplify it later on. So the next part of this expression is we have a negative c. X times negative c is going to be negative xc, right? And then same thing, we're going to do y times 1 when we just get y. So we're going to further simplify this, which is going to be xb, which is x times b, minus x times c, and then we're going to get is y times y is just y squared, and then this is just going to be y by itself. So this is our final solution after we have expanded using distributive property. So now we're going to move on to a more complex expression, and we're going to try and multiply using or use distributive property, what we just learned. So let's start with this first term. Now we know that xy, so x times y, divided by a squared is being quantified by xyc divided by a plus 2yc minus 4 divided by a squared. So this time we have fractions on the outside, we have fractions on the inside. Same thing over here, we have fractions on the outside, and we have fractions on the inside. So let's try simplifying this further. Or we can say we can expand this. So let's start with the first term. So xy times xyc divided by 8. So what you know, xy times xy is just x squared and y squared. Because x times x is x squared and y times y is y squared. In this case, we don't have a c beside it, so we're just going to add the c. The c doesn't change. Let's move on to the denominators. So a squared times a is going to be a cubed. When you have exponents, we add the exponents when we're multiplying. Remember, this is an imaginary 1 right here. So 2 plus 1 is going to be a cubed. Okay. Let's move on to the next term. We keep this operation. This operation doesn't change because this is also a positive xy divided by a squared. If this was a negative xy a squared, then this operation may change. But in this case, positive times a positive is going to result in a positive. So let's try this out. Now we're going to multiply this xy divided by a squared by this 2yc. So we have no x's in this term right here. So we're going to leave the x by itself, but we have a coefficient. We're going to keep that coefficient where we're going to have a 2. And we're going to do x. Since there's no x in here, we're going to keep our x. And then now we have a y. So remember, this y has a 1 exponent and this y has a 1 exponent. When we're multiplying two terms, we're going to add the exponent. So this is going to be a y squared. And then in this term right here, we don't have a c, so we're going to keep the c as well. So let's divide now. Let's do the denominator. So we have an a squared. Remember, this is over an imaginary 1, right? It doesn't change the expression, but it's over an imaginary 1. So a squared times 1 is just a squared by itself. Now, we have a positive number being multiplied by a negative number. So our term. So a positive times a negative is going to result in a negative. So here is where our operation changed. When we multiply a positive times a positive, the operation didn't change. But when we multiply a positive times a negative, as you can see, the operation changed to a negative. So we have xy times 4. Since we don't have a y and an x in this term, we're not going to change it. We're going to keep the coefficient of 4, and we're going to multiply by xy. Now we're going to multiply the denominators. So we have an a squared and an a squared. When we multiply two terms with exponents, we're going to add exponents. So what we're going to get is a to the 4th power. So there is no further simplifying that we can do or expanding, because all of these terms are different. We cannot add or subtract any of these terms. But what we can do is we can make sure that all of our exponents are in the right order. So let's say, for example, here we have an x squared and a y squared, so that's fine. Just going to rewrite that. And then here we have a cubed, which is also fine. Here what we did was we have a 2x, but we also have a y to the power of 2. The y to the power of 2 should come in first because it should be in chronological order. So it should be y squared, and it should be decreasing exponents. Since the x is over a 1, the x would come next, or the c could come next. It doesn't really matter. And we're dividing this all by a squared. Here we have 4x times y. We're going to subtract 4x by y. This is fine. And then we have an a to the 4th. So this is also fine. So at the end, what we can conclude is that when we're distributing, when we're using distributive property on fractions, always remember that the numerator multiplies with all the numerators and the denominator multiplies by all the denominators. The better that we can get is when we can start skipping this step in the middle. We can straight go to the answer by just using distributive property. We don't have to write down this. So this whole thing can get crossed out the more and the better that you get with distributive property. And this definitely comes in handy when you're working with larger polynomials, larger trinomials and everything. This definitely gets way easier. So I hope everybody used this information to the best of your ability. And another video is coming up pretty soon, and I hope you enjoy the rest of your day.